Look at logarithms and exponentials. This has been something that we've been building up to in this book or in this school year with Algebra 2, and this is the time we actually get to figure it out. So we've been at a place where we've tried to solve for x up top in an exponent, and we've had a hard time being able to do that. So this lesson is going to teach you that. So if I have 5 to the x power equals 20, I know if I took 5 to the first power, I'd have 5. 5 to the second power is 25. So I know the answer to this is something a little bit less than 2. So in order to figure that out, I need to have a function that brings this x down. Well, what we're going to learn is that if we have an understanding that this is an exponential base 5, because this is my base and this is my exponent, then to undo that, I need a logarithm base 5. So a logarithm base 5 is what I'm going to take on both sides. So I'm going to do log base 5 on both sides. And on this side, I've got log base 5 next to exponential base 5. And it looks like this. So that's the undoing operation for exponential base 5. Just along the same lines of thinking that you probably know that if I have x squared, if I want to get rid of it, I take the square root. So you know that squareds and square rooting are inverse operations. You now need to learn that if I have an exponential base 5, that a logarithm base 5, and this is the base for the logarithm, are also mathematical inverses. So a log base 5 next to exponential base 5, these will cancel, and x will equal log base 5 of 20. Then in order to solve that, the last thing we need to talk about is being able to do the change of base property so I can plug this in my calculator. Because right now this is logarithm base 5 and I need it in base 10, as our numbering system is everything in base 10. So then I can take the top divided by the bottom, and I would end up with log base 20 divided by log of 5, and that is what you would plug in your calculator. And the log key that we're talking about is adjacent to the number 7, so we can just do log of 20 divided by log of 5 and get that answer. So log of 20 divided by log of 5, and the solution is 1.86. And I knew it was going to be close to 2, so I can approximate that with squiggly equals 1.86. Okay, a second example is what if I have 11 to the x equals 122? Well, this is exponential base 11, so I'm going to do log base 11 on both sides. Log base 11 of 11 to the x, log base 11 of 122, then log base 11 next to exponential base 11, those cancel, and x equals log base 11 of 122. Take the top divided by bottom by the change of base property, and log of 122 divided by log of 11, and I'm going to get the solution, and it should be a number that's just a little bit greater than 2, because I know that if I were to divide, I end up with, or do the division of the two logs, and I end up with 2.0034. So my approximate answer is 2.0034. Okay. The other skill that we practiced today is being able to rewrite a log into exponential form. Well, here we did the log base of 11 on both sides. Well, if you start with a log base 12, to get rid of it, you need to do exponential base 12. So put a big 12 on both sides. Then you have exponential and log bases next to each other. Those cancel. And 144 equals 12 to the second power. Well, you know that. Another one is, if I have log base 5, I can do exponential base 5 on both sides. You're putting an exponential base 5 on both sides. Those cancel, and I end up with 5 to the 6th power equals 15,625. And then I've got that is a true statement. Sometimes they ask you a simple thing like just evaluate log base 7 of 30.6. Well, that's easy. Just take the top divided by the bottom and type that in your calculator. So you just simply type in log of 30.6 divided by log of 7, and you've got the solution, 1.758. Next one, same thing with this. Just take that divided by that. So you just do log of 11 divided by log of 3. Now, a couple other key concepts that we talked about today, and this will wrap it up here real quick, is that the key points are log base 3, which looks like this, and exponential base 3, which looks like that, are inverses of each other. So they cancel each other when you do them to both sides. Next, every answer to a logarithm question is an exponent. Every single time you solve a log question, you're finding or calculating an exponent. I'm finding an exponent by using logs. And then the change of base property is this whole idea where I can just take the top divided by the bottom. So I can do log of 28 divided by the log of 3, and I can actually solve for x, and you can type that in your calculator. Go through the video a couple times, slow it down, take a look at it. It'll make sense. Good luck.